to cap.read. So that will give us our frame. We will write cv2 dot wait key 1, and we will write cv2 dot im show, and we will write here image, and we will write img. So this is basically what we always do to run a webcam. And what we can do as well is write here that if, or do we need, or we can skip it, it's fine. We don't need to write that we have to close with the Q button. So here we can right click and we can press the run button. And let's see. So there you go. This is my webcam. You can see my hand. There you go. And we are going to detect this hand. So the first thing we have to do is we have to create an object from our class hands. So here we are going to write, now this is related to the hand detection module, or the hand detection model. So later on we will create our own module so that we can learn how to use it easily in different projects. So getting the values of these different points or the landmarks is a little bit tricky, but we will create a module so that we can just say, I want the point number 5 of the hand. So tell me the location. So that will become quite easy to use in different projects. So first of all, we are going to write here mp hands is equals to
Hello Moto.
Motorola का Edge 60 Pro grade triple 50 megapixel AI camera system. Motorola Edge 60 Fusion 1.5K का all curved display. Moto G96 5G segment best 144 Hz OLED display.
Celebrate with Motorola phones now at unbelievable prices.
mp use in different projects. So first of all, we are going to write here mp hands is equals to mp.solution. Now this is, you can say, a formality that you have to do before you can start using this model. So you will write mp.solutions.hands, and then we are going to write that we are going to create an object called hands. We will write mp hands.hands, and then inside that we have to write our parameters. Now what are these parameters? So let's go and check them out. So we will press the control button and we will right click on this, and it takes us to that function. So here we can check what exactly are we getting. What exactly do we have to input? So here the first thing is the static image mode. So static image mode, they have this configuration where they will track and detect. So if you put this as false, then sometimes it will detect and sometimes it will track based on the confidence level. But if you put it as static mode, then the whole time it will do the detection part, which will make it quite slow. So we will keep it false so that it detects, and if it has a good tracking confidence, it will keep tracking. So this way it will be much faster. Whenever the tracking confidence goes lower than a certain range, then it will do the detection again. So then you have the maximum number of hands. So here we have 2, and then we have the minimum detection confidence. So this is 50%, and then minimum tracking confidence, which is 50%. So it means if it goes below 50%, it will do the detection again. Okay, so now that we know our parameters, we can go back and we can write here false. So actually we are not going to write anything because these are the default parameters and they have already given the default values. So we do not have to change or write anything here. If we want to, we can, Otherwise, we can skip it as well. So for this instance, we are going to skip, and later on, we are going to write whatever we need. So then we are going to go, actually, we'll need to go back. Okay, so then here in the loop, we are going to send in our RGB image to this object. So here we have to first convert it. So we will write here image RGB is equals to cv2.cvt color, and then we will write our image. Y is a double bracket. Okay, we will write our image, then we will write cv2.color underscore bgr to RGB. So this is our idea, that we want to convert it into RGB because this class or this object only uses RGB images. So we need to convert that first. So we will write here that our results is equals to hands. So we are calling this object dot process. So there is a method inside this object called process that will process the frame for us, and it will give us the results. So that's how simple this is. Now all we need to know is how to extract this information and use it. So after this, what we can do is we can simply display this, but at this point we are not really displaying or doing anything, but I still want to run it to see if everything is working so far. So it will be processing it, but it will not display anything for us. So let's try it out. So there you go. And now you can see, even though it's processing, the frame rate has not decreased. It seems real time. We will later on check the exact speed as well, the exact frame rate. So don't worry about that. Okay, so then we are going to open this object up, the one that we have received, and we are going to extract the information within. So as we have seen the parameters, we can have multiple hands. So what we can do is we can extract these multiple hands. So we will have to put in a for loop to check if we have multiple hands or not, and we have to extract them one by one. Now, before we do that, we have to make sure that there is something in the results. So we can print out the results and we can run it. And it just gives us that it is a media Python solution base solutions output. And if I bring in my hand, nothing really changes. So we need to know when something is detected or not. So to check if something is detected or not, we can write here dot multi underscore hand underscore landmarks. So let's run this and see what happens. So here it says none, and if I put my hand, and there you go. So straight away we are getting some values. So what we will do is we will say that if we can remove the print, or let's keep the print, we can copy this part and we can go down and we can write here, if this is true, then we are going to go in and for each hand, so we can say for each hand landmarks, let's say, in results dot multi, whatever we wrote here, multi-hand landmarks. So you saw that we were getting some results. So is it of one hand or two hands? We don't know. Well, we actually know because I just put one hand, but it could be of multiple hands. So here we will have each hand, and then we will get the information or extract the information of each hand. So once we do that, we have a method provided by the media pipe that actually helps us draw all these points, because there are a lot of them, and you have almost, how many were there? 21 points. And between each point, if you want to draw a line, it will be quite a lot of maths that would be involved there. So they provided us with a function or a method for that. So we are going to write that down. And that is basically mp draw, we will call it mp draw, is equals to mp.solutions dot drawing utilities. So we will write that, and now we will use mp draw to actually draw it. So we will write here mp draw, and then we are going to write draw landmarks, and inside that we will give in our image that we want to draw on. So we don't want to draw on the RGB image because we are not displaying the RGB image, we are displaying the original image BGR. So we will write image, and then we are going to write hand LMS. So this is a single hand. Okay, so there could be multiple hands. This is, let's say, hand number 0. Then there could be hand number 1. So this is that single hand. So if I run this now, that should draw the hand for us. Let's try it out. And there you go. So now you can see it is drawing the hand for us, and it looks pretty good. So, but these are points, and I told you that we could draw the connections as well. So how can we do that? We can do that by writing here mp hands dot hand underscore connections. So that is it. So we are using mp hands dot hand connections, and this will draw the connections for us. So let's try that out. And there you go. So now you can see how easily we got our hand position, and we got all the 21 landmarks. If you like the video so far, give it a thumbs up, and don't forget landmarks.